Today we are going through Physics Paper 4 062542 October-November 2021 paper. Question number 1. Figure 1.1 shows a space rocket accelerating away from a launching pad. Figure 1.2 is a speed time graph for the first 30 seconds of the rocket's flight. And you can see the speed time graph here. Part A says describe how the acceleration of the rocket changes between 10 seconds and 30 seconds. So we need to describe what happens between this. As you know that acceleration is gradient of speed time graph, right? You can see here that the gradient of the graph increases in between this time. So we can write here that acceleration increases and we get 1 mark for this. Part B says by drawing a tangent to the graph, determine the acceleration of the rocket at time t equals 25 seconds. And as you know that acceleration is gradient of the graph, we can use the formula y2 minus y1 divided by x2 minus x1. And to find these values, we have to go and see the graph. They told us to find gradient at t equals 25 seconds. We can see here that it's going like a straight line over here, so we can just take this point and this point here and we can find our gradient. So this is gonna be our 21, 22, 23, 24, 25, 26, 27, and this point here is gonna be 1550, and here this point is gonna be our 1150, and the x-axis is gonna be 22. So we have x2 as 27 and x1 as 22 and y2 as 1550 and y1 as 1150. So we can plug in our values. We have y2 as 1550 minus y1 as 1150 divided by 27 minus 22, and we get our answer as 150 divided by 27 minus 22, 80. So 80 meters per second square is gonna be our answer. Part C says determine the distance traveled by the rocket between 0 and 10 seconds. So you find distance by speed time graph by using area under the graph. So we have here is 400 and we have 10 here. And how do you find the area? We use the formula for triangle because this is triangle. So it's going to be half into base into height. So half into base, which is 10, into height, which is 400, and we get our distance. And to find this distance, we just use our calculator, and it's going to be half into 400 into 10, which is going to be 2000. So the answer is going to be 2000 meters. And we are done with question number 1. Question number 2. Part A says state Hooke's law. This is a very simple definition. They usually ask it in like every year. So we can write our definition here that extension of spring is directly proportional to the load applied on the spring. So that's what Hooke's law means. Part B says figure 2.1 shows the extension load graph of a spring. And here this is extension. Note that this is in millimeter and load which is in newtons. So part I says on figure 2.1 mark and label the region where the spring obeys Hooke's law. As you can see here, till this point the graph obeys Hooke's law, and after this point what happens is that the graph slightly starts increasing. So our Hooke's law, which is Spring's Hooke's law is gonna be here. So we can write it's gonna be our Hooke's law. So this is what we get for 1 mark. And then part 2 says calculate the spring constant. So for calculating spring constant, we are given with extension and load here. We only have one formula for that, F equals Kx. And to find K, we need force divided by extension, which is going to give us spring constant. So the extension at this point is 145, and the load applied on this is 20.5. We can just plug in our values of F and X and find out the spring constant. So our F is 20.5 and X is 145, and don't forget to convert this into meter, which is going to be into 10 raised to the power minus 3. So it's going to be like this, and we can use our calculator for this, which is going to be 20.5 divided by 145 into 10 raised to the power minus 3, and we get our answer as 141.3, 141.37. We can just round it off to 140, and we get our answer as 140 newtons per meter. Don't forget the unit. And if you're wondering why is this newtons per meter, you know that K equals F by X. Unit for F is Newton and X is meters, and there's a division sign in between, so that's why it's newtons per meter. Part 3 says the original length of the spring is 120 millimeter. Calculate the length of the spring when a load of this is applied to the spring. So we can use the same formula again, which is going to be F equals Kx, and force this time is 8.5, and we have K, which we found out in our first part, which is 140, and we need to find X this time. So we can just rearrange our formula, and it's gonna be 8.5 divided by 140, which is gonna give us 0.5 divided by 140, 0.060. So 0.060, and this is in meters. And what we found out is extension, not the length. So this is extension. For finding out the length, what we have to do is plus this, which is the original length of the spring, which is going to be 120 plus 60. If you convert this into millimeters, you get 60. So you can just add this up, or what you can do is convert this into meters first, which is going to be 120 into 10 raised to the power minus 3, and add up 0.060. It's better to use the SI units. So 120 into 10 raised to the power minus 3 plus 0.060, which is going to give us our answer as 0.18 meters. Or if you want, you can just write it as 180 millimeter. So don't forget the units. If you don't write the units, you won't get marks because they didn't specify any unit to write in. So you have to mention, if you're writing in meters, you have to mention it's meters. If you're writing in millimeters, you have to mention that it's in millimeters. Only then you're going to get your answer and marks for that. Part C says the weight of an object is 4 Newton on a planet where the acceleration of free fall is 8.7 meters per second square. Calculate the mass of the object. So we have to calculate mass, and we're given with F and A. So we know the formula what we have to use. We have to use F equals ma. We are given with F, we are given with A, so we have to make m the subject. So m equals F divided by A. Force is 4 and acceleration is 8.7. So we can find out our mass. 4 divided by 8.7, which is going to give us our answer as 0.4597. So we can just round it off to 0.5 0.460. So our answer is going to be 0.460, and it's going to be in kg because mass is in kg. And we are done with question number 2. Question number 3. Figure 3.1 shows a collision at very slow speed between two cars traveling along a straight road. Car B of mass 800 kg is moving at speed of 2 meters per second and collides with car A of mass this, which is 1000 kg, which is stationary. After the collision, the both cars travel in the same direction as the initial direction of car B. Part A says after the collision, car A moves at speed this. Show that the speed of car B after collision is approximately 0.4. So how do we find this? Is we have the formula, which is total momentum before the collision is equal to total momentum after the collision. And the formula for that is m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. So our m1 is this, m1, u1 is this, and m2 is this, and we are given with after the collision car A moves at speed this. So our v2 is this, and in the question it says we have to show the speed of car B after collision is approximately 0.4. So we can just put in our values, which is going to be m1, which is 800, into u1, which is 2, plus m2, which is 1000, into u2. Before the collision it's 0, so 0 into 1000 is going to be 0, which is equal to total momentum after the collision, which is going to be m1, again 800, and we have to find v1, which is going to be x. We can just put anything, you can even write v1, plus m2, which is 1000, into v2, which is 1.3. So to find out this, now what we have to do is just rearrange our formula and make our x as the subject. So we get our final equation as 2 into 800 minus 1300 divided by 800, which is gonna give us our value of x. And to find the value of x, we can use our calculator. 2 into 800 minus 1300 divided by 800, which is going to give us our answer as 0.375, which is approximately equal to 0.4 meters per second, and we get 3 marks for this. Part BI says calculate the impulse exerted by car A on car B. So before the collision both cars are separate, so there is no impulse. Before the collision it's 0. But after the collision, we have impulse because both cars are moving together. And in the question it says, calculate the impulse exerted by car A on car B. So we have to find the impulse of car A. And impulse of car A is going to be change in momentum, which is mass into velocity. So mass of car A is 1000, and velocity of the car after the collision is given as 1.3, so we have to use this 1.3 here. So when we write 1.3 here, 1.3, so we get our answer as 1300, and this is going to be our answer for part BI. Don't forget to add the units, which is going to be newtons per second because it is impulse. Part 2 says state the impulse exerted by car B on car A. For this part, you know that change in momentum remains same for both cars. And since change in momentum is same, our impulse is gonna be the same. So it's gonna be 1300 as well, newtons per second. And we are done with question number 3. Question number 4. Part A says a power station uses wind energy to generate electricity. State and explain whether this method of generating electricity is renewable. You have to give a statement and explanation for this. So the answer for this is going to be renewable because wind is an infinite energy resource, so we can't run out of it. So we can write that as our explanation and we can write out our statement as well. It's a renewable method, and the explanation for this is going to be wind is an infinite energy resource, so you can't run out of it. And we get 2 marks for explaining and writing the statement. Part B says state 2 energy resources that do not have the sun as their source. So we have many examples. If you have read the textbook, you know that we have many examples. We can write 2 of them. So geothermal is one of them. And the reason it doesn't have sun as the source because it includes the process of decay of radioactive particle in Earth's core. So if you're not familiar with this, go read the textbook again and try to solve the past paper again. For the second energy resource we can write as tidal energy. And the reason behind that is because it involves movement of tides or oceans, and it has nothing to do with the sun's energy. So we get 2 marks for this. Part C says for energy resource, state the form of energy stored in for each energy resource. So fossil fuels, of course, you know it's chemical energy, and water behind hydroelectric dams is going to be gravitational potential energy. So for this we can write is chemical energy, and for this we can write is gravitational potential energy, and we get 2 marks for this. And we are done with question number 4. Question number 5. Part A says a thermocouple thermometer is used to determine the temperature difference between a mixture of ice and water and liquid mercury at approximately 600 degrees Celsius. Complete figure 5.1 with a label diagram to show how the thermocouple thermometer can be used in this way. So if you have learned about thermometers, you would know that thermocouple consists of 2 wires. So we can draw our thermocouple here, and this is going to be our thermocouple. There are going to be 2 junctions over here, and these are going to be connected with wires, 2 wires. One wire is going to go from here mixture of ice and water, then the other one is going to go here to the liquid mercury, and both of them are going to be wire A. This is going to be wire A as well, and the wire B is going to go from mixture of ice and water to liquid mercury. This is going to be our wire B, and this is how you draw label diagram for thermocouple thermometer. And we can even write here, this is our thermocouple, and these are our 2 junctions. This is junction 1, and this is going to be our junction 2, and we are going to get 3 marks for this. Part B says state 2 other physical properties that can be used to measure temperature. So what else can we use is we can use expansion of liquid, and the other one we can use is expansion of gas. And for this we'll get 2 marks. There's nothing much to explain for this. You just have to go and read the topic for this. These are like basic theory questions. If you don't understand, you have to go and read the textbook. Part C says state 2 benefits of using thermocouple thermometer instead of liquid in glass thermometer. So what are the benefits of using thermocouple thermometer instead of a regular thermometer? Let me draw a regular thermometer as like this, and it has some kind of liquid in this, and when you heat the bottom, what happens is that the liquid expands and it goes up. So this is how normal thermometer works. So we have to compare the normal thermometer with thermocouple thermometer. So what benefits are there is that you'll get more range, and the other benefit you'll get is that it has small thermal capacity, so it can measure high temperatures. As it has small thermal capacity, it measures high temperatures. And we are done with question number 5. Question number 6. Figure 6.1 shows particles of material in which a sound wave is traveling, and you can see here the wave. And part A says on figure 6.1 mark the center of a compression with the letter C. Part 2 says the center of rarefaction with the letter R. And the third part says one wavelength with a double-ended arrow. So we can see here what is compression. Compression occurs when particles are like closest, and rarefaction occurs when the particles are further apart. So I have highlighted. So this is going to be our compression, and this is going to be our rarefaction. And what's going to happen is for one wavelength, how can we measure one wavelength is from this point, it should be another similar point. So it's going to be till here. So we can draw a line like this and point two arrows. And this is going to be answer for our part A. So this is refraction, compression, and one wavelength, which we can write it as lambda. Part B says circle one value from the list, which is the speed of sound in water. And as you know, the speed of sound in water is around 1450 to 1498. This gives us only one answer, which is 1500, which is the closest here. So we can circle that. And the other values are going to be wrong because they're very high, either very high or very low. Part C says the wavelength of sound wave in water is this. So we have lambda over here. Calculate the frequency of sound wave using your value from B, part B, which is here. So we have to use this and the wavelength. For this question, what we have to do is use the formula V equals F lambda. And since we are finding frequency, we can make F the subject. So V value we have 1500, which is going to divide by 12 into 10 raised to the power minus 2, as this is how you convert centimeter to meters. So we can put this on our calculator, 1500 and then 12 into 10 raised to the power minus 2. So this is gonna be 12,500, and we can round it off to 13,000. So our answer is gonna be 13,000 hertz. Don't forget the units. So part D says state and explain whether the sound in part C, which is this, is ultrasound. For a wave to be ultrasound, it has to be above 20 kHz. So it's not ultrasound wave. So we can write here no. And the reason we can write is ultrasound has frequency above 20,000 hertz. So as this is lower than 20,000, it's not an ultrasound. We are done with question number 6. Question number 7. Figure 7.1 shows a ray of light approaching face AB of a glass prism of refractive index 1.5. And you can see here the ray of light approaching AB. Part AI says on figure 7.1, accurately draw the path of the ray within the prism from face AB to face AC. You will need to make a measurement from 7.1 and carry out a calculation. So it should be accurate. That's why they're giving 4 marks for this question. So for this, what we have to do is first of all draw our normal line. So our normal line is going to be here. And we know that when light travels from less dense to dense material, it moves towards the normal. So our light is going to be towards the normal. And for drawing the refracted ray, we have to do is find our angle of refraction. So for finding angle of refraction, we use the formula sine I divided by sine R equals the refractive index. Refractive index in this case is 1.5. So what we can do is we can first measure the angle of incident from the normal, which is going to be 60 degrees, and we can now rearrange our formula to find R. So when we rearrange our formula, we get as sine I divided by n equals sine R. What we did is we just brought this here and this on the other side, so we get this part. And when we get this part, what we can do is we can just remove the sine from here and write sine inverse on this side. And by writing this, what happens is we get our angle of refraction. So we have sine incident angle as 60, so sine 60 divided by a refractive index, which is 1.5, which is going to give us angle of refraction. And by using our calculator, what we can do is find our answer. So it's going to be sine 60 divided by 1.5, which is going to give us our answer as 35. So our refractive right is going to go 35 degrees away from the normal. So it's going to be like this, and it's going to hit the boundary of AC, and this angle is 35 degrees. We get 4 marks for this. So part 2 says determine the angle of incident of ray when the light strikes face AC. So for this, what we have to do is draw a normal line again, which is going to be like this, and we have to find the angle, this angle, and this is approximately 10. So we can write our answer as 10 degrees, and we get 1 mark for this. Part B says without further measurements or calculations, sketch on figure 7.1 the approximate path of ray after passing through face AC. So after passing through AC, what will happen is as it's going from dense to less dense, what will happen is it's going to go away from the normal. So it's gonna be like this. This should be 35 plus, okay, 35 plus degrees, and this is gonna be our path of the ray. Part C says figure 7.2 shows a ray of light traveling within an optical fiber cable. Okay. Part I says complete the path of ray of light to the left hand end of the fiber. So what happens is, as you know, in optical fiber there is total internal reflection, so the angle between the rays is gonna be 90 degrees. So it's gonna be 90 here, then again it moves here, this is gonna be 90, then again it moves here, it's gonna be 90 as well, then again it moves here, it's gonna be 90, and then at the end it's gonna be like this, and all the angles should be 90 degrees. Part 2 says name the process taking place at X. I just told you that it's total internal reflection. And we are done with question number 7. Question number 8. Part A says figure 8.1 shows a conducting object A, initially uncharged, held on an insulating stand. The positively charged rod B is brought close to object A. This is charged rod B, which is here, and conducting object A. Part I says on figure 8.1 draw the distribution of charges on object A. So what we have to do here is draw the distribution of charges, and as you know, positive charge attracts negative charge, so this side of the object is going to be negatively charged and the positive charges will move on this side. Part 2 says a wire is connected from object A to Earth. So we have a wire which is connected to Earth. State and explain any movement of charge. Explain your answer. We have to give a statement and explanation. So what is going to happen is object A will become negatively charged And the reason is that all the positive charges will leave from here to the earth. We can write the reason here as all positive charges will move to earth, or you can write ground, and we get 2 marks for this. Part B says there is a current in wire this milliampere for 2.2 minutes. Calculate the charge that flows. So we are given with I, which is 0.65 into 10 raised power minus 3 ampere, and we're given with time, which is 2.2 into 60, which is going to be seconds, and we need to find charge, which is Q. So the equation which relates this is Q equals IT, and we can just plug in our values and find out our value of charge. So it's going to be 2.2 into 60 into 0.65 into 10 raised power minus 3, and this is gonna give us our answer into 60 multiplied by 0.65 into 10 raised power minus 3, and our answer is gonna be 0.058. We can round it off to 0.0860, and we are done with question number 8. Question number 9. Part A says figure 9.1 shows a cell of electromotive force EMF 1.5 voltage and a battery of EMF 6.0 connected in series, and calculate the combined EMF of cell and the battery. So total EMF is gonna be 1.5 plus 6.0, as it is in series, so it's gonna get add up, which is gonna give us 7.5 voltage. And part B says the combined resistance of 3 resistors shown in figure 9.2 is 4.4 ohms. Part I says calculate the resistance of R. So to find out R, what we can do is total minus this, which is gonna give us R. So our total is 4.4, and we have to find, let's say this is X minus X is gonna give us our value for R. So how do we find X? Well, the resistance are connected parallel, they're not in series, so we can use our formula, which is R1 into R2 divided by R1 plus R2, and we get our resistance for this. So for this, what we can do is 3 into 2 divided by 3 plus 2, 3 into 2 divided by 3 plus 2, which is gonna give us 1.2, and this is our value for X. So 4.4 minus X, which is 1.2, is gonna give us our answer as 3.2. So our resistance of R is gonna be 3.2 ohms. Part 2 says the current I in figure 9.1 is 0.94 ampere. Calculate the potential difference across the combination of resistors. So we are given with I, which is 0.94. We have to find potential difference, and our total combined resistance is 4.4, as it says find potential difference across the combination of resistors. So we have to use the total resistance, which is 4.4, and it's given above in the question, which is 4.4. So we use this, and our formula which we have to use in this case is V equals IR, and we have R, we have I, so we can find out our potential difference, which is going to be 0.94 into 4.4, which is going to give us our answer as 0.94 into 4.4, 4.136, and we can round it off to 4.14, 4.14, and then don't forget the units. We are done with question number 9. Question number 10. Part A says name the logic gate shown in figure 10.1. And as we can see here, it is OR gate. We can just write OR gate. Part B says figure 10.2 shows a combination of logic gates. This is NOT gate and this is NOR gate, NOT, and this is NOR gate. And the reason this is NOR is because this circle is there in front, which indicates that it is not OR. Complete the right-hand column of table 10.1, the truth table for the combination of logic gates. You may use the blank column for your working. So what happens is we have input I, then we'll have output I, and then there will be two inputs again, which will give us output O. So what we can do is first we can solve this part, which is going to be input I will give us output I. So we can write here output I, and the answer for this is going to be opposite of the inputs because it's a NOT gate. So 1 and 0, and output O is going to be our NOT OR. So we can write the truth table for OR gate. 0 plus 0 is going to give us 0, 1 plus 0 is going to give us 1, and 0 plus 1 is going to give us 1, and 1 and 1 is going to give us 1. So this part is for OR gate, but for NOR gate it's going to be opposite of the outputs, which is going to give us 1 0 0 0. So the only condition where both inputs are 0, the output is going to be 1. So in this case what happens is output I is taken in by the NOR gate. So the only condition where the output is going to be 1 is when the both inputs are 0. So in this case both inputs are 0, so our output is going to be 1, and the other one is going to be 0 as NOR gate doesn't give output 1 in any other input. Part C says an electric device has a metal case. Explain the benefit of earthing the metal case. So what happens is when you earth a metal case, the charged particles will move to ground. And what will happen is that if someone touches the metal case, the person is not going to get electrocuted. The metal case, the person is not going to get electrocuted. And we'll get 2 marks for this. Part D I says explain how a fuse protects a circuit. So what happens is when the current flow is high, the fuse breaks, or what happens is the fuse melts down. Fuse breaks or melts down. And what's going to happen is there will be no current flow and it won't cause a fire or any malfunction in the circuit. So stops flow of current. And we get 2 marks for this. Part 2 says the current in electric kettle connected to the mains through a fuse is 10 ampere. Fuses with the following rating are available. Circle the correct fuse rating for this appliance and explain your answer. Since the fuse will melt down or break when the current is equal to the rating, if it's equal to the rating, what will happen is the fuse is going to melt down or it's going to break. So this cannot be our option. And if the rating is lower than the current, what is going to happen is it's going to break earlier. When the current is 3 ampere, the fuse is going to break. So these are not going to be our option as well. So our option is going to be from these both, and we are going to take 13 because the fuse rating should be slightly higher than the current passing through the fuse, so that if the current changes to 12 ampere or 11 ampere, it doesn't break down, and the kettle only needs around 10 amperes. That's why. But if we use 30 ampere of fuse, what's going to happen is the kettle only needs 10 ampere and the kettle is going to burn down. So that's why this is not going to be our option as well. And we can just explain our answer that fuse rating should be slightly higher than the current passing through. And we are done with question number 10. Question number 11. Part A says describe the composition and structure of a neutral atom of beryllium-8 which has a proton number of 4 and nucleon number of 8. So in this question, what we have to do is we just have to explain the structure of neutral atom. So an atom contains of nucleus which has electrons surrounding it, and inside the nucleon is neutron and protons, right? So this is how an atom structure looks like. We just have to explain this in writing. So what we can write here is nucleus is surrounded by electrons. The nucleus contains proton and neutron. And to get our last mark, what we have to do is mention that it has 4 protons and 4 neutrons in the nucleus. It has 4 protons and 4 neutrons in the nucleus. And how do you know that? Because this is the nucleon number, and if you subtract 4, because the number of proton and number of electrons are same, we get 4 as our answer. So that's why we have 4 neutron, and we get 4 marks for this. Part B says a radioactive isotope decays by beta emission to form an isotope of barium with nucleon number 135. So we get barium as our product, and we have beta emission as product as well. So we can write down here that in product we have Ba and plus we have beta particle. Now we can write the nucleon number and the proton number. In the question it mentions that the nucleon number of barium is 135. So we can write 135, and we can find out the proton number of barium from here, which is 56. And as we know that beta particle doesn't have anything in nucleon, so it's going to be 0. And for proton, the charge is going to be -1. So we can just add these both and get our reactant. For this, what we have to do is 135 plus 0, which is going to be 135. And then we have to do is 56 minus 1, which is going to be 55. And we can just see that which element has 55 protons is going to be our reactant. So it's going to be CS. And this is pretty much from this question. You'll get 1 mark for adding CS and 1 mark for 135 nucleon number on the left side. And for writing barium and showing beta particle on the right side, you get 2 marks. So you get 1 mark for this, 1 mark for this, 1 mark for this, and 1 mark for this. And total is going to be 4 marks. We're done with the paper. I hope it was helpful to you. If you have doubt in any questions, just comment down below. I'll try to respond as soon as possible. And see you in the next video. Bye bye.